This is the masterclass video for the topic of electromagnetic spectrum. Let's start with a very quick recap of the topic. The electromagnetic spectrum consists of 7 components: gamma rays, X-rays, ultraviolet rays, visible light, infrared radiation, microwaves, and radio waves. And the trend in frequency from gamma rays to radio waves, as seen on the screen, is that the frequency decreases, meaning gamma rays have the highest frequency and radio waves have the lowest frequency. The trend in wavelength is opposite to that of frequency. From gamma to radio waves, the wavelength is increasing, meaning gamma rays have high frequency but short wavelength. Radio waves have low frequency but long wavelength. The properties that are common to all the 7 electromagnetic waves are they're all transverse in nature. They travel at the same speed of 3 times 10 to the power 8 meters per second in vacuum. All waves transfer energy from one place to another. All of them show wave properties like reflection and refraction, and they also obey the wave equation of speed is equals to frequency multiplied by wavelength, v equals to f lambda. You need to be able to know some common applications of all the 7 electromagnetic waves, and it is summarized by these 2 tables here. You may pause this video to take a longer look through the applications and uses of the electromagnetic spectrum. The first question. The component Q in the question has frequencies below that of light. What are electromagnetic waves in component Q used for? To answer this question, we first need to fill up the electromagnetic spectrum. Gamma rays, X-rays, ultraviolet rays, visible light, infrared rays, microwaves, because as seen from the question, from the left to the right, from radio to gamma, it is increasing frequency. This is the table that we saw earlier. Now, for Q, which we now identify as infrared rays or infrared radiation, the use is D in television remote controls. What are the electromagnetic waves in options A to C used for? For killing of cancerous cells, gamma rays are used. For satellite television, microwaves are used. There's a star there because this is a very common question, so please make sure you are familiar with this. For sterilization, especially of medical equipment in hospitals, ultraviolet rays are used. The next question. Electromagnetic waves have many applications. For the 4 applications listed in the table, for mobile phones, which electromagnetic waves are used? Again, recall this table very quickly. For mobile phones, microwaves are used. For sunbaths or sun tanning, ultraviolet rays are used. For television remote controls, as we learned in the previous question, infrared rays are used. For satellite television, also revised in the previous question, microwaves are used. Among the 4 electromagnetic waves stated in table 3.1, microwaves, UV, infrared, microwaves also, which has the greatest frequency? We recap the trend in frequency as we move from gamma to radio. Gamma have the highest frequency. There's no gamma rays in this table. The next one will be followed by X-rays, which is also not used in table 3.1. Therefore, among the 3 that are used, ultraviolet rays will have the highest frequency from table 3.1. What is the speed of ultraviolet waves in a vacuum? All the electromagnetic waves travel at the same speed of 3 times 10 to the power 8 meters per second in a vacuum. With this speed given, what is the frequency of UV waves if the wavelength is given as 10 nanometers? We're going to use the formula of V equals to F lambda. Speed is frequency times wavelength. Frequency is the speed divided by the wavelength. What you need to take note of is the wavelength has a prefix of nano. Nano is represented by 10 to the power of minus 9. So remember to add in 10 to the power minus 9 for your wavelength. and you will get the frequency of 3 times 10 to the power of 16 Hertz. What is the order of magnitude of the diameter of a typical atom? The diameter of a typical atom is from 1 times 10 to the power minus 10 meters to 5 times 10 to the power minus 10 meters. When they ask for the order of magnitude, it means that it's in a range of 10 to the power minus 10 meters. For the second part of this question, which region of the electromagnetic spectrum in figure 11.1 in the question has a wavelength that's similar to the diameter of an atom? We can see that 10 to the power minus 10 meters is very small, so it will likely lean towards nanometers, which is the smallest prefix in figure 11.1, compared to micrometer that's represented by 10 to the power minus 6. Therefore, 10 to the power minus 10 meters is how many nanometer? You divide by 10 to the power minus 9 meters, represented by nano, and you should get 0.1 nanometers. Therefore, it should be X-rays. Radio waves, microwaves, and infrared waves are used in telecommunications. State one use of each of these electromagnetic waves in telecommunications. What you need to be careful about in this question is that the specific use is in telecommunications. Therefore, you cannot state that the use for microwaves is, for example, in microwave ovens, nor intruder alarms, for example, for infrared waves. The use must be in the form of telecommunications. So for radio waves, they're used for direct radio and television signals or communications. For microwaves, it is something that we have been revising at the beginning of the video as well, which is in satellite communications. For infrared waves, it will be used in remote controllers for television sets.